So far in the course, we've been primarily looking at the integer data type. Now, the Java primitive there's actually additional integer data types, and what I want to do in this video is we're going to start exploring those further. And if you remember, we did talk about them a few videos back in the course, and primarily the different integer types. And integer, again, that is a whole number that does not have any decimal places. These different types for the primitives are primarily based on how much space they're going to take up in bits and bytes inside the computer. So I'm going to jump over to a slide deck and do a quick review of the Java primitive integer types that we have available to work with. So up on the screen, I have a list of the Java primitives, and we can see here that the byte takes up 8 bits of memory, while the short takes up 16 bits. The int or integer that takes up 32-bit, while the long takes up 64 bits. And you can see here they all default to 0, but the range of numbers that can be held within these variables is very highly dependent upon how large that number is going to correspond to the number of bits that it takes. So a byte is the smallest. That goes from 127 up to negative 128. Remember, integers are positive and negative. And then you can see that the short is much larger at 32,000 and some change. And then we get into some much larger numbers with the integer, and finally the long, that is a fairly large number that we can work with in the Java programming language. The primary takeaway is to remember that these do have a maximum size that they can hold as far as the number, the byte being the smallest, the long being the largest, and then you need to be aware of hitting these size limits in terms of the maximum value that they can hold. The next thing to remember here is that we have implicit casting and explicit casting, and we will take a closer look at that coming up in this video. And this is a chart that you can use for your reference. If you don't have to declare the cast, that is called implicit. It just happens. However, with explicit, you can get effectively what's called truncation, where values will get adjusted to the maximum size of that variable. And we'll be looking at that as examples coming up in the course. But again, that's just a refresher on the primitives, not only the integers that we have available to work with, but also the type of casting. And these slides will be in the course resources where you can download them and use them for your studies. Now, the first Java primitive that I want to give you an example of is the byte. Remember, the byte takes up a single byte, or 8 bits of memory. And let's jump over to IntelliJ now and take a look at an example of declaring a byte inside of Java. Okay, to look at integers, let's go ahead and create a new Java class. I'm going to just do right-click, New Java Class. I'm going to call this integer examples, and this will be in the course resources for your reference. Now let's go ahead and declare the main class. That's going to be public static void main, and that's the abbreviation for the shortcut. And to declare a byte, all I need to do is use the Java keyword byte, B-Y-T-E. I'll just call this my byte, like so. And I can just assign this a value of 1, which is going to be perfectly fine for our purposes here. And just like a integer, if I do the shortcut for system out, I can say my byte. And then I can use the concatenation operator to go ahead and get the output like so. And if I run this, we will get an output of 1 to the console. And you see that I did, in fact, get 1 output to the console. Next, we want to look at working with the short primitive. The short, again, that takes up 16 bits, or 2 bytes of memory. And I'm going to jump over to IntelliJ now and show you exactly how to declare a short within the Java programming language. Now let's go ahead and also declare a short here. So I'm going to come in here, and again, that's just going to be a short, and I will call this very creatively my short equals, and again, a 1 value is perfectly fine for our purposes right now. And again, I'm going to do a system out, call it my short, and use the concatenation operator for my short to output that value. And let me go ahead and run this, and we'll see the short value output to the console. And you can see that both of these are set to a value of 1 at this point in time. Now, throughout the course, we have been looking at the int or the integer data type quite a bit. And in this video, what I want to show you is the corresponding reference type. So remember, we talked about we do have primitives and reference types. Every primitive does have a corresponding reference type, and I'm going to show you a trick here that we are going to take the maximum value for an integer, the int type, and assign that to the integer variable that we're going to declare, and I will use the property from the reference type to do this. I'm going to jump over to IntelliJ and show you exactly how to do that now. Okay, so I'm going to come into IntelliJ here, and again, just going to use the int or the integer type, and I will call this my int. And here I want to assign it the maximum value. So I'm going to use the reference type, and that is going to be integer. And now I can say max value. So you can see it. I've got a property for max value and min value. You can actually see that that is actually a hex value, but that does correspond to a number. So we will use max value here. And now I am going to come down here and do another sys out. And I will call this my int. And let's go ahead and do an output of that. So my int there. And let's go ahead and run this, and we will see that maximum value output to the console. You can see that's a fairly large number. I don't feel like going through and doing all the commas on that, but a fairly large number for the maximum value of an integer. Now, the long data type is kind of a special use case for us. So far, we've been able to just declare a whole number and assign that to the variables for all the integer types. Well, long is a special use case because the compiler needs to know when you've gone above the maximum integer value. I'm not quite sure why this is. This is just one of those rules within the Java programming language. A lot of times you'll see people declare longs with an L. It's only required when the value of the long that you're declaring is greater than the maximum integer value. So I'm going to jump over to IntelliJ now and show you how to declare a long value. Let's take a look at declaring a long value. So I'm just going to come in here, say long, my long equals 1, like so. And we can see here, this is happy with that. So if I do a system out, and I'm just going to append or concatenate the long value to it. And here, I go ahead and run that. And you can see that that does output okay. Now, if I want to change this and reassign that, so I am going to copy this maximum integer value, and we can see that is okay. So not getting any errors right now, but if I come back over here, and I'm just going to change this to 99, now we can see IntelliJ is giving me a warning that says integer number too large. So now that I've exceeded the maximum integer value, the Java compiler is saying I need to use the L literal to assign that value. So now if I go ahead and run that, we will see that this my long value is now larger than the maximum integer value allowed on the system. I do want to reiterate, the long is the only value where you need to use this as far as the Java integers go. You do need to declare that L if it is larger than the maximum integer value. So very important distinction. If it's smaller, you can declare it like you can see on line 8 where I just did the number. So as long as it's smaller than the maximum integer value, you can just use the number. If it's larger, that is where you must use the L. So we've been looking at the integer types, and we talked about implicit and explicit cast. Now, if Java can go ahead and safely convert the data type, it's going to do so. So remember, Java is a strongly typed language, and we saw how a byte can hold a very small range of numbers, but if we go from a byte to a short, or a short to an int, or an int to a long, all these values can accommodate the entire range of the smaller container. However, the inverse is not as true. If we are going down in size, obviously we run the risk of truncating that value. But when we are able to go ahead and do the type conversion automatically without the risk of loss of data, that is called an implicit conversion. So Java is going to implicitly do that type conversion for us. So I'm going to jump over to IntelliJ now and show you exactly what I mean by an implicit conversion, where Java is saying, yes, you are going from something smaller to something larger, so you don't have to declare your intention to the compiler. So I'm going to jump over to IntelliJ now and show you exactly how this works. Okay, let's take a look at doing an implicit type conversion here. So I'm going to come in here, and for my byte, let's reassign that. So I'm going to say my byte, and remember, we do have that reference type of byte. And now I can use the max value. So a max value of 127. So now that is assigning 127 to byte, but I can also take my short and assign that to the value of my byte, like so. Because remember, the short value is going to hold a lot more than a byte. And this is going to work happily here because I'm doing an implicit type conversion. On line 11, I am not telling Java that I'm going from a byte variable to a short variable. I don't have to declare that. So if I go ahead and run this, we will see that my short gets the value of my byte, which is 127, but that is well within the capacity of short. So if I remember right, the short is like 32,000 and some change. So very much so well within the capacity of my short. So I do not have to explicitly declare the type conversion here. So this is what we mean by an implicit type conversion. And likewise, if I come here and say my short, and now I'm going to do the short, and I can do the max value of my short, like so. And now I can say my int is equal to the short value as well, because remember the int is a much larger value than the short. And now I can run this, and everything is going to be happy. And we can see that it's 32,767 is the maximum value of a short, and that gets assigned to the maximum value of an integer, which works out happily because that is well within the maximum value of an integer. Now, the other type of cast that we've got to look at is the explicit cast. So this is where I am going to, as a developer, tell Java I want to go from a larger variable to a smaller variable, and I am taking responsibility for the contents of that. So if I have a really big number and I go to a smaller number that can only hold a smaller number, obviously bad things could happen where I'm going to lose that additional information because that variable will not fit in the smaller container. But Java does allow us to do this through an explicit type conversion. So this is a feature of the Java programming language. There are times where you want to do this, but also be aware you can cause yourself some problems by doing this, because if you're going from a 10-pound bag to a 5-pound bag, you still have 5 pounds of stuff that went away. So just keep that in mind, that when you are going to a smaller variable, you could potentially lose data. And Java's going to let you do this. So be aware. This is one of those where you do have control, and Java does allow you to do this, but you can get yourself in trouble. And I'm going to jump over to IntelliJ now and show you how to do explicit type conversions. Now here we're going to be taking a look at explicit type conversions. So now if I come in here and I'm going to take my long here, and I'm going to assign that to the maximum long value. So if I do long.max value, like so, that assigns that to the largest long value. Now, if I want to come back and assign that to my integer, like so, what I cannot do is just go like this. We can see here I'm getting a red squiggly under there, and this is telling me that IntelliJ is definitely not happy. And if I try to run this or compile it, the Java compiler will say, no, you can't do that. So what I have to do here is an explicit type conversion. And I'm going to be casting this. So if I come to this and say int, like so, so now I am doing a cast, and I'm saying take that long value and cast it to an integer. So now if I run this, we're going to get some more interesting results. So here you can see my long, I have a nice long number there for my long, but my int now that is a -1, so meaning that I've wrapped around. So the Java compiler has not provided a very good way. So basically that number wrapped around. So we not a desirable behavior because we are doing that cast there. And I can also do this with, I can do my short equals, and now I can say short. So I'm going to do a declaration of short and say that it's coming from my long, like so. And let me run this again, and we'll see the short value. That also goes to -1. And then I can also say my byte equals. So you can see the truncation that's happening here, and this is not really a predictable result, how these are going to -1. I really don't care for that behavior, but again, I am doing an explicit type conversion here. So let's see if I do a -10 there. I'm just curious to see what happens. So on line 14, I'm doing my long -10 from the maximum value. It'd probably stay -1. Let's see. I'm kind of curious. Oh, so it goes to -11. So not really the behavior that we are looking for as to how things are wrapping around inside the compiler as these are running. But the primary thing I wanted you to learn from this portion of the video here is on line 15. What I'm doing is I'm taking the myLong variable and I am explicitly declaring that as an integer, and you can see I'm getting some rather unsavory results, some things that I really don't want in my program. But again, I am telling it that this is the value that I want. Now, if I were to change this, I could say this is equal to, let's say this 2000L, like that. So if I declare the long value to that, let's go ahead and run this now. And we should see some different results. So you can see that what is that, about 200,000 there? So that fits in a long, that also fits in an integer, but it does not fit in the short, nor does it fit in a byte. So you can see the truncation that has happened in those values when I'm doing that explicit type conversion. So you are going to get a truncated value, and the value that you get may not always be predictable. So something that you definitely want to be careful of. But if you are in a programming in a situation where you do have smaller values, this is something that is valid to do as long as you are aware of the risk that you are dealing with when that truncation can start occurring, because you can see Java's happy to do it. It goes ahead and truncates those values, and it doesn't complain, doesn't give you any warning. It just lets you do it, and you can get some rather unpredictable results there.